Good morning, students. Children, now we will be starting with your Science and Technology Part 1, Chapter number 12, Study of Sound. Are you able to hear me? Yes, maybe. Yes or no? Yes, you are able to hear me very properly. Yes? Now, so today we are going to study about the sound. What is sound? How is sound produced? Okay? So here in this video, we will be discussing about the introduction to sound. What is sound, students? Sound is nothing but it's a form of energy which creates the sensation of hearing in our ears. So, sound is a form of energy which creates the sensation of hearing in your ears, and this energy is in the form of waves. Then, children, if your teacher is teaching you, you are able to listen my voice. Okay, your video is on, you are able to listen the audio. What is very necessary? What is very necessary for propagation of sound waves? A medium is very necessary. There should be a medium. Unless and until the medium is not there, the sound waves are not going to be produced. Okay. Sound waves give rise to the chain of compression, places of higher density and refraction, and place of lower density in the medium. So sound waves gives rise to the compression and rarefaction. Now what does it mean? Now this we will be understand with the help of a certain concepts. The particles of mediums oscillate about their central or mean position in a direction parallel to the propagation of the wave. Such waves are called the longitudinal waves. Such waves are called as the longitudinal waves, and these longitudinal waves, on the other hand, the waves created by dropping a stone in a still water, the particles of water oscillate up and down. The oscillation are perpendicular to the direction of the propagation of the waves. Such waves are called transverse waves. So there are two different types of waves created. One is longitudinal and another is the transverse waves. These waves help to carry forward the sound. Children, here we have started with the introduction of the sound. In our next video, we will be continuing same with the introduction of the sound, and we will be trying to understand the concept of waves more properly. So remaining we are going to see into the upcoming videos. Good morning, children. Now still we are continuing with your concept about the waves, and we are studying about the introduction to the sound. Now here we will be studying about the sound waves. Okay, so how are the sound waves created, and what are the differences in the types of sound of waves? Now, children, I want you all to keep your textbooks with you so that whatever I am teaching, you can simultaneously refer your textbook. A sound wave can be shown in the form of graph. At any moment during the propagation of a sound wave, we would find alternate bands of compression and rarefaction of medium, that is, bands of greater and lesser density. In figure 12.1a, the figure shows the changes in the density, while figure B shows the changes in the pressure. The changes in the density or pressure are shown in the form of graph in the figure C. The wavelength of sound is indicated by the Greek letter lambda, and its frequency is indicated by the word nu. The amplitude, which is the maximum value of pressure or density, is indicated by A. The time taken for one oscillation of pressure or density at a point in the medium is called the time period and is indicated by T. The value of frequency determines the pitch, high or low of the sound, while the value of amplitude determines the strength or loudness. Now children, here we have studied the various concepts regarding the sound waves. Okay. Now once again I am coming back to the first slide. So your first 12.18, it indicates the changes in density. Your 12.1b diagram indicates the changes in the pressure, where the 12.1c, it shows the graph of density and pressure. So children, there are various factors which are related to the sound, okay, and there are different propagation mediums, and at any time you have to keep in mind that there are various denotations to express the letters. Like sound waves, wavelength is indicated by the Greek word lambda, the frequency is indicated by nu, and the amplitude, which is the maximum value of pressure or density, is indicated by the capital A. These are certain values which you have to keep in mind. Children, we are stopping our video now. Remaining we will be studying in the upcoming videos. Good morning students. Welcome to today's lecture. Today we will be studying about the sound. Now children, we have to study about the velocity of sound. Children, in your previous chapter, laws of motion, we have started with the definition of speed and velocity, and we have studied the differences between the speed and velocity. So by the time you reach to this chapter, your concept about velocity is, I hope, much more clear. So now we are going to study about the velocity of sound. The distance covered by a point on the wave, for example, the point of highest density or lowest density in unit time, is called the velocity of the sound wave. So distance covered by the highest velocity to the lowest velocity is known as the what? It is known as the velocity of the sound wave. In particular time, how much the highest and the lowest distance is the sound wave covering, that indicates the velocity of the sound wave. The equation for velocity, you know, velocity is equal to distance upon time. At point on the sound, the waves covers the distance equal to lambda, that is wavelength, in the point time t, in the time period point t. So here your formula will be velocity is equal to wavelength upon time period. Therefore you can say that v is equal to lambda upon t. Thus you can say that the velocity of the sound is equal to wavelength into the frequency. Okay, velocity is, you can say that, wavelength into the frequency. If any medium, in any medium at fixed physical conditions, the velocity of sound of different frequencies is very nearly the same. The velocity is highest in solid and the least in the gases. The velocity increases with an increase in the temperature of the medium. Means suppose if there is a high temperature, the velocity will also be the more, and if the temperature increases, the velocity of sound also decreases. Italian physicists Borelli and Viviani in the year 1660s first calculated the speed of the sound. They measured the time between seeing the flash of a gun and hearing its sound from a long distance. The value of 350 meter per second is very close to the value of 346 meter per second, which is accepted today. So these were the first who calculated the velocity of the sound, and today we are calculating, which we have accepted, is the 346 meter per second. So children, here we have studied about the velocity of the sound. Remaining we are studying in the upcoming videos. Good morning students. Now we will be studying about the velocity of the sound. We are continuing the next part about the velocity of the sound. Now children, velocity of sound in a gaseous medium. First we are here studying the velocity of the sound in the gaseous medium. So students, the velocity of the sound in gaseous medium depends on the physical conditions, that is temperature, density of the gas and its molecular weight. velocity, the temperature are having some relationship. What is the relationship that we are going to study now? So the velocity of the sound is directly proportional. See children, just hear the sentence properly. The velocity of the sound is directly proportional to the square root of the temperature of the medium. This means the temperature, that increasing the temperature 4 times doubles the velocity. Okay, so you can say that velocity is directly proportional to the square root of temperature. Then density. The velocity of sound is inversely proportional to the square root of density. Thus, increasing the density 4 times reduces the velocity to its half. If you will increase the density by 4 times, you are going to reduce the velocity to the half. And the molecular weight. So the velocity sound is inversely proportional to the square root of molecular weight of that gas. Thus, increasing the molecular weight 4 times reduces the velocity to half its value. Means if you will increase the molecular weight 4 times, then the velocity of the sound is going to get reduced to the half of its value. So children, here we have studied the effect of different identities on the velocity of the sound. The identities we have studied about the molecular weight, density and the temperature. So these are the factors which are having the effect on the velocity of the sound. Depending upon the nature of these factors, the velocity of the sound changes from one medium to another, and also depending upon the surrounding conditions. Okay children, remaining we will be studying into the upcoming videos. Please children, read the textbook, kindly follow the textbook, go through the videos as much as time your concepts are not very firm and you are not revising the chapter. So it will be very easy for you to understand it more properly and watch the videos. And remaining we are going to study into the upcoming videos. Children, stay home, stay safe. Good morning students, welcome again. Now children, today we will be studying about the audible, infra and ultrasound. So the limits of hearing of human ear are 20 Hz to 20,000 Hz. This means the human ear can hear sounds of frequency in this range, and hence this range is called audible sounds. These sounds are called audible sounds. Our ears cannot hear the sound of frequency lower than 20 Hz and higher than 20,000 Hz, that is 20 kilohertz. So from here you can see that your audible frequency is 20 Hz to 20 kilohertz. Okay, or 20 kilohertz. If I want to convert into the hertz, it will be 20,000 Hz. Sound with frequency of smaller than 20 Hz is called infrasound. Sound which frequency is less than 20 Hz is called the infrasound, whereas the sound produced by the pendulum and the sound generated by vibrations of the earth crust just before earthquake are examples of these sound. Sound waves with frequency greater than 20 kilohertz are called ultrasound. The dog, mouse, bat, dolphin, etc. have a special ability to hear the ultrasonic sound. Thus, they can sense some noise which are inaudible to us. So here you understand the children, certain animals like dog, mouse, bat, dolphin, they can hear the sound. They are blessed with the qualities to hear the sound which we human beings are not blessed with. Okay, you can hear only from 20 Hz to 20 kilohertz, but certain animals are there which are having the property, which are blessed with the, you can say, ability to hear the sound more than 20 kilohertz. Okay, so children, many times we have seen that when earthquake is there or tsunami is there, it was observed that the animals' behavior changes drastically. Immediately those animals and their cows, they just try to break the chains and run. The only reason because is that these animals have sensed that there is change in the earth's crust. Regular sound is not there. Some problem can arise, and hence these animals' behavior changes immediately before you can say tsunami or earthquake. It has been observed by many scientists, and even we have studied and we have read about that. The children under the 5 years of age and some creatures and insects can hear the waves with frequency of 25 kilohertz also. Bat, mice, dolphin, etc. can also produce the ultrasound. So certain animals are also there like bats, mice and even the dolphins. These are able to produce the ultrasound. Okay. Uses of ultrasound. Now we are going to study about the use. What are the uses of ultrasound? So first uses, it is used for communication between ships in the sea, to join the plastic surface together, to sterilize the liquid like milk by killing the bacteria in it so that the milk keeps for a longer duration. So these are the certain uses of ultrasonic sound. Next, echocardiography, ECG, which we are saying ECG report. Echocardiography, which studies the heartbeats, is based on the ultrasonic waves, sonography technology, to obtain the images of internal organs in a human body. And it is also used in industry to clean the intricate parts of the machine where hands cannot reach. Ultrasound is also used to locate the cracks and faults in the metal blocks. Okay. So these are the certain uses which we have studied about the ultrasound. Remaining we are going to study into the upcoming video. Now children, welcome. Good morning students. We are going to study now the reflection of sound. What do you understand by the reflection and how does the sound reflect? Okay. Now in your previous chapter you have studied about the reflection of light. You know, in the way the light reflects, in the same way the sound waves also get reflected. Okay. Now, so same thing like light waves, sound waves too get reflected from a solid or a liquid surface. These waves also follow the laws of reflection. A smooth or rough surface is needed for the reflection of the sound. The direction of the incident sound wave and the reflected sound wave make equal angles with the perpendicular to the surface, and all these three lie in the same plane. Now we are going to study about the certain good and bad reflectors of sound. Okay. So, how much of the incident sound gets reflected is decided whether a reflector is a good or a bad reflector. So, if the sound wave falls on a particular object, how much how much sound waves are reflected back from that object, that factor decides whether your surface is a good reflector or a bad reflector. Okay. So a hard and flat surface is a good reflector, while clothes, paper, curtain, carpet, furniture, etc., these absorb the sound instead of reflecting, and therefore these are called as the bad reflector. So now you have understood the concept of good reflectors and the bad reflectors. The good reflectors are the object which are hard and flat and through which the sound can pass, and the bad reflectors are like clothes, paper, curtains, carpet, furniture. These absorb the sound waves. These take the sound waves in itself instead of reflecting back, and hence these are called the bad reflectors of the sound. Children, this good and bad reflectors you can compare with the good and bad conductors of electricity which you have studied. Okay, so then that time your concept will be becoming more clear about the good reflector and the bad reflector. Okay children, here we should stop our video. Please read the textbook, revise the lesson, so your concept will be becoming more clear. Good morning children. Children, today I am going to ask you one question before I start this video. Can you name any nearest hill station near Badlapur? Near a place? So the first name will come to you is Matheran, Lonavala, Khandala. Now, those who have visited these places, there are many different points, okay, when you visit this point, and those who have visited, they know that there is an echo point. Even in Mathेरान also we are having an echo point. If anyone has visited that point, they will be understood that what teacher is going to teach today. So yes, today I am going to teach you about an echo. Okay, so now we are going to study how the echo is formed when you go to a hill station, okay, and you might have visited an echo point in a hill station, okay. So what happened if you shout loudly at such a point? You hear the same sound just after a little while, and that sound is called an echo. So how is an echo formed? What is echo? That we are going to study now, okay. So this might be a question for you since many years ki how is an echo form. Those who have visited unko bahut, so they might have feel very much now that how it is formed. So then here your concept becomes clear that an echo is the repetition of the original sound because of reflection by some surface. And in the previous video you have studied that sound also reflects as the light reflects. So hence you can say that echo is the repetition of the original sound because of the reflection or by the some surface. In order to be able to hear the original sound and its reflection distinctly at 22 degrees Celsius, what must be the minimum distance between source and the reflecting surface? Okay, so there should be a particular distance between the source and the reflecting surface, okay, then only the sound is going to reflect. So at 22 degrees Celsius the velocity of sound is 344 meter per second. At 22 degrees Celsius, when the temperature is 22 degrees Celsius, the velocity of sound is, yes, 344 meter per second. Your brain has capacity to retain the sound for 1 second. Your brain is having the capacity to maintain or to retain the same sound for 1 second, and hence for us to able to hear a distinct echo, which the sound should take more than 0.1 second after starting from source to get reflect and come back to us. Okay, so your sound should take more than 0.1 second. So from starting it should go to the surface and again reflect back and come to you. Thus we can determine the minimum distance between source and the reflecting surfaces as follow. Distance is equal to speed upon time. So speed is 344 meter per second and time is 0.1 second. So your required distance is 34.4 meter from where you can listen the sound very properly. Thus, to be able to hear the distance echo, the reflecting surface should be minimum distance of half, that is about 17.2 meter, and thus the velocity of time sound depends upon the temperature, and this distance depends on the temperature. Now here we have studied in today's video how the sound gets reflected. Remaining we will be studying into the upcoming videos. Good morning students. Students, have you ever visited an auditorium? Or do you notice when you have visited to watch any movies, certain places are there where the voice is not very clear. Okay, in the cinema house or in the auditorium or in the movie theaters, sometimes some places are there where the voice is not very clear. Do you know the reason behind that? Okay, so today we will collectively study the reason behind that. So when we will be studying reverberation of sound, your concept will be becoming clear that why certain places in cinema halls are not having good quality of sound. Just see, a singer is singing over here, listener is sitting, and the sound waves are reflected from many directions. Just see the pointed arrows. Okay, you will be understanding that the sound waves are reflected at multiple points and they are reaching to the listener. And when these many reflections will reach the listener, obviously the person won't be able to hear any voice correctly. And this is about the theory of reverberation. Now, sound waves get reflected from the walls of roof of a room multiple times. Whatever you speak, it gets reflected multiple times, and this causes a single sound to be heard not once but continuously. This is called the reverberation. The time between successive reflections of a particular sound wave reaching us becomes smaller, and the reflected sounds gets mixed up and produce continuous sound of increased loudness, which cannot be deciphered clearly, which cannot be heard clearly. Okay, and this is the reason why some auditoriums or some places in the auditoriums have inferior sound reflection. So this we have shown already in the figure 12.3. So now you might have understood that in some places, many times when you go and watch in auditorium, you watch any drama, sometimes it will come that certain places the voice is same and same sound is repeating again and again. That is nothing but it is due to the multiple reflection of the same sound, and due to the multiple reflection as shown in this previous diagram. See, there is a multiple reflection, and then it gets mixed, and hence the person who is sitting over there is not able to focus on any one sound, and hence it feels that the sound is reverberating, or it is known as the reverberation of the sound. Okay, so children, today we have studied about the reverberation of the sound. Kindly watch the videos as you have to improve more your concepts clear, and go through the textbooks and read the textbook, so your concept will be becoming more clear. Good morning students, hope you all are fine. Children, today we are going to study about the concept of the sonar. What is sonar? See this diagram. If you watch this diagram clearly, you will be able to see that there is a transmitter and a receiver shown. Okay, there is a transmitted phase and reflection phase, and water is there and seabed is there, and the diagram is labeled as the sonar technique. Now here we are going to study what is the sonar technique. Sonar is the short form for sound navigation and ranging. It is used to determine the direction and the speed of an underwater object with the help of ultrasonic sound waves. So see, this diagram will show you that it is a technique which is useful to study the direction, distance and speed of an underwater object with the help of the ultrasonic sound waves. And you know, this ultrasonic sound is inaudible to human ear. Only but few living organisms are able to hear this sound. Okay, now sonar has a transmitter and a receiver, as I have discussed previously in the previous slide, which are fitted on the ships or boats. The transmitter produces and transmits the ultrasonic sound waves. Thus, the waves travel through the water, strike underwater object and get reflected back by them. The reflected waves are received by the receiver of the ship. So just I am going through the diagram. See, here you are able to see transmitter is there. Transmitter is emitting the sound. The sound goes and it touches in any object and it reflects back, and the sound is received by the receiver of the ship. The receiver converts the ultrasonic sounds into electrical signals, and these signals are properly interpreted. The time difference between transmission and reception is noted. So if you want to calculate the depth of any underwater object, this is the best technique, because you yourself cannot go by taking a measuring tape and going inside the sea and measuring the distance. This is practically not possible. So what the methodology scientists have produced, they are using the sonar technique, that is sound navigation and ranging. With the help of this technique, they are calculating the time difference between transmission and reception of the sound. This time and velocity of sound in water gives the distance from the ship of the object which reflects the waves. Sonar is used to determine the depth of the sea. Sonar is also used in the search of underwater hills. Children, you should know there are big mountains underwater also. Okay, we are able to see, we say that the Mount Everest is the highest peak, but even under the seas also we are having mountains as big as Mount Everest. So the sonar technique is used to study the underwater hills, valleys, submarines, icebergs and the sunken ships, etc. Now children, here we have completed the study of sonar sound. Remaining we are going to study in the upcoming videos. Please watch the videos as much as time possible so your concept will be becoming more clear. Good morning students. Now children, today welcome, and we are going to study some interesting fact today about an interesting technology, that is a sonography. Most of you have heard very common word sonography na? Generally when a person is suffering from a stomach ache or having any problem from n number of days, when doctor is not able to understand, then doctor suggests the person to go for a sonography. So what is sonography? See this machine? Yes, this is sonography machine shown in the first two diagram, and then the next diagram is the image obtained by the sonography. Sonography technology uses ultrasonic sound waves to generate images of internal organs of the human body. So it's used to generate the images of internal organ of human body. This is useful in finding the cause of swelling, infection and pain. So if there is swelling in the internal part, any infection is there, if it is paining, so this technique is used for determining the cause. Condition of the heart, the state of the heart after a heart attack, as well as growing fetus inside the womb of a pregnant woman are studied using these techniques. This technique makes use of a probe and a gel. The gel is used to make proper contact between skin and the probe so that full capacity of the ultrasound can be utilized. The gel is applied to the skin outside the internal organ to be studied. High frequency ultrasound is transmitted inside the body with the help of the probe. The sound reflection from the internal organ is again collected by the probe and fed to the computer, which generates the images of the internal organ. As this method is totally painless, it is increasingly used in medical practice for correct diagnosis. So since there is no pain in this method in sonography, hence most of the medical diagnostics, they refer this method for problem finding of the internal organs. And then there is a moral, there is a thought given for you all, awareness campaign, that Beti Bachao and Beti Padhao. So in short, I am just going to explain you what is the Beti Bachao. Nowadays we are saying save the girl child. So since this technology helps us to study the internal parts of the human body, many times this technology is misused and it is caused to reduction on the number of the girl child. Okay, so we should not use the technology for any negative purpose. Instead we should go with its actual use. So many times now fetal detection or the gender detection of the fetus is avoided all over India. So here you are not able to know the gender, because by using this technology there was a great loss suffered to the girl child previously, few years before. So now it has completely female foeticide is an crime, and person found in that may have some fine and imprisonment. They may be even, they are having authorities to push the person in the jail if any person who is found involved in certain activities. Okay, so here we have studied about the sonography. Remaining we are studying in the upcoming videos. Bye children, stay home, stay safe. Good morning students. Children, today we will be starting with the next section of your science and technology part 1. Today we are going to study about the human ear. Children, this is a diagram of human ear given in your textbook. You can refer it from your textbook as I am explaining you the chapter, as I am explaining you the concept. Children, we all know that we are having 5 sense organs, and out of that 5 sense organs, your ear is an important organ. Okay, so we hear the sound because of our ears. So when sound waves fall on the eardrum, it vibrates. These vibrates are converted into electrical signals which travel to the brain through nerves. Your ear can be divided into 3 parts, that is outer ear, middle ear and the inner ear. Outer ear or the pinna. Children, you know that the outer ear collects the sound waves and passes them through a tube to a cavity in the middle ear. It is peculiar function, funnel-like shape. It helps to collect and pass sounds into the middle of the ear. The middle ear is a thin membrane in the cavity of the middle ear is called the eardrum. When the compression of a sound wave reaches the eardrum, the pressure outside it increases and it gets pushed inwards. The opposite happens when the refraction reaches there. The pressure outside decreases and the membrane gets in outwards. Thus, the sound wave causes vibrations of the membranes. In the inner ear, the auditory nerve connects to the inner ear to the brain. The inner ear has a structure resembling to the shell of a snail, and hence it's called as a cochlea. The cochlea receives the vibrations coming from the membranes and converts them into electrical signals, which are sent to the brain through the nerves. The brain analyzes these signals, and in this way we are able to listen the sound and we are able to hear the words which are coming to us. This is all due to the function of your ears. Children, you should know that your ears are very delicate parts. Your ears are one of the sense organs. It's very necessary for everyone to take care of our ears. We should keep the ear clean. Never put any sharp object in your ears which may cause damage to the eardrum. Children, this was regarding the ear and its function. Remaining we are going to study in the next video. Good morning, children. Children, today we will be studying about the solved examples of your chapter Study of Sound. The first example is, how long will it take for a sound wave of 25 centimeter wavelength and 1.5 kilohertz frequency to travel a distance of 1.5 kilometer? Here frequency is given 1.5 kilohertz. Okay, if I want to convert it into hertz, it will be 1.5 into 10 raised to 3 hertz. Wavelength given as 25 centimeter. If I want to convert it into meter, it will be 0.25 meter. Distance is given 1.5 kilometers, which is equal to 1.5 into 10 raised to 3 meters. We have to find the time, that is t. Velocity of sound is equal to frequency into wavelength. Okay, by inserting the values, I am getting 1.5 into 10 raised to 3 into 0.25. After multiplying these, I am getting the value 0.375 into 10 raised to 3, and my value for V is 375 meter per second. Now I know that time is equal to distance upon velocity, and if I want to calculate the time, I am knowing the distance, I am knowing the velocity. So I will divide the distance by velocity, and my answer is 1.5 into 10 raised to 3 divided by 375. My answer is 4. So I know that the sound wave takes 4 seconds to travel the distance of 1.5 kilometer. A second example is, the ultrasonic waves are transmitted towards the sea with the help of sonar. The reflected sound is received after 4 seconds. What is the depth of the sea at that particular place? Velocity of the sound in water is 1500 meter per second. The given values are: velocity of the sound in sea water is 1500 meter per second. The time of echo to be heard is 4 seconds. Time taken by the sound to reach the bottom of the sea is 4 divided by 2, that is 2 seconds. And by following the formula, velocity is equal to distance upon time, I am getting distance is equal to velocity into time, and the depth of the sea I am getting 1550 multiplied by 2, that is 3100 meter. So the depth of the sea is, children, 3100 meter. Now the next question. Sound waves of length 1 centimeter, wavelength of 1 centimeter have velocity of 340 meters per second in the air. What is their frequency? And can this sound be heard by human ear? So first I have calculated the frequency. Is wavelength is given, that is equal to, values are given. If I calculate, I am getting the value. Wavelength is given as 1 centimeter. Velocity is given 340 meter per second. V is equal to nu upon lambda. Therefore, I am getting the value, that is 340 into 10 raised to 2. Therefore, the frequency is 34,000 hertz. Whereas you know that human ears cannot hear the frequency more than 20,000 hertz. Therefore, this sound cannot be heard by human ear. Children, here the chapter gets over. I am sending the notes. Kindly complete in your Science 1 journal notebook.